Morning, everybody, and welcome to that great conference and welcome to our presentation. Twins are something very special. Especially the connection between these two persons is unique. Even in mechanical and plant engineering, twins are mentioned increasingly, but here they are called digital twins. Today, Teresa, Alberts, and me want to present you a special kind of a digital twin, a so-called the simulation-based digital twin. So what's a simulation-based digital twin? How does it work? And what are the first steps of GEMÜ towards this new technology? And what are the main benefits for our customers? So we want to invite you to a journey which symbolizes a revolution for mixing processes within valve technologies. But first, a short introduction. My name is Marco Wissinger, and I'm a development engineer at GEMÜ. I've been with the company for 2 years now, and I'm working in the pre-development department at GEMÜ. Teresa.
Hello, also from my side. My name is Teresa Alberts. I'm the CEO of ITficient and had the pleasure to do the project management for this project with Marco.
So I will go on just with a short introduction of GEMÜ, my company. GEMÜ was founded in 1964 in a small city in the northern part of Baden-Württemberg. GEMÜ is today one of the global leading manufacturers of valves, control and measurement systems, and considering sterile application, GEMÜ is here the market leader. Starting with 1 employee, GEMÜ has grown to a company with more than 1,900 employees with a total turn group over more than 330 million euro. GEMÜ is of course not only represented on its German sites, which you can see here on the slide, but also in 50 countries on all continents, including 26 subsidiaries and 6 production plants. To give you more information about the organizational structure, I prepared the following slide, and in general, GEMÜ is divided into 4 major business units. The first business unit is displayed now here on the slide. You can see it's the business unit Food, Pharma, Biotech, and the representative product of this business unit is the so-called multi-valve port block, or short it's M block, made of stainless steel, which has very good capabilities in cleaning and it's very space saving. The second business unit is the business unit semiconductor, which is a very fast-growing one. And here, valves made of plastics and M blocks made of plastics. Some special kind of plastics is a fluoropolymer due to the aggressive media our customers use in their processes. The third business unit is the business unit industry, and here high demands on lifetime and huge cross-sections are with our products. And the last one I want to mention is a short or a small one. A small business unit is the business segment medical, and here our products are involved into complex analysis and lab machines of our customers. Here you can see a single-use valve body which is mounted underneath one of our electric drives. So GEMÜ is not only developing and manufacturing electric drives, but also pneumatic and manually driven drives. To give you more information about the customers of GEMÜ, you can see here some representative customers on the slide. For the business unit industry, companies like Kaeser, Züblin or Solvay could be mentioned. Companies with the food pharma biotech market are probably much more familiar for you. So it's companies like Pfizer or Roche, which could be mentioned. And for the business unit semiconductor, it's companies involved into chip manufacturing or suppliers for this chip manufacturing. And it's Samsung, for example, BASF or Bosch. Products of GEMÜ and their usage at our customers' processes are of course not that familiar for people like you, which are not involved into the world of valves in general. So therefore I prepared a picture on which you can see example process, example for a bioreactor or fermenter, which we developed and manufactured for one of our customers. The main purpose of this bioreactor is to grow some certain bioculture in its tank. And as you can see in the slide, the dimensions of this bioreactor is not that big, at least compared to some other processes of our customers. I prepared a schematic drawing of this bioreactor, and as you can see, it's pretty complicated, but indeed it is. So you can see all the components which are involved into the process, and it's not only the growing of the bioculture, but it's also the sterilization process and the cleaning process, which has to be considered while manufacturing and engineering the process. And to give you more information about the importance of the GEMÜ valves which are involved in this system, I colored all the GEMÜ valves included here in red. So as you can see, there are quite a few GEMÜ valves involved, and that they are very important for the operability of the system. Going on with the pains and the challenges our customers have to face every day in their daily work. So, for example, today there is almost no life insight into their production processes due to the lack of physical sensor data. Of course, the asset costs are pretty high. It's due to the requirements of our products to get easy to clean and have a high purity. The processes of our customers are pretty complex, so the performance of these processes have to be evaluated while engineering these processes in advance for a lot of different boundary conditions. Of course, downtime is pretty expensive, so it's downtime due to maintenance, it's due to failure, or for example, cleaning of these processes. And the last thing I want to point out is a very important one, in my opinion, because the product quality of our customers' products is often, of course, pretty critical. So think about, for example, medicines, think about pills, think about vaccines, or even food. So we searched for a technological way to tackle all these challenges and pains, and therefore we found the concept of the simulation-based digital twin of a valve system. Going on with the prototype of the simulation-based digital twin we developed here at GEMÜ. It's a simulation-based digital twin of a mixing system which allows us to give a real-time live insight into a simple mixing process. So we used an amp block, as this one displayed here on the slide, which has two inlets. So, and the main purpose is to mix two volumetric flows of hot and cold water. So it's namely cold water at 20 degrees Celsius and hot water at 80 degrees Celsius to create a certain mixing average temperature at the outlet of our amp block. The problem is, and that's of course the main motivation then for our prototype. Today, no information about the local temperature distribution and no information about the homogeneity of the flow is given to our customers, because these values are almost impossible to measure with real sensors. So today there's no live monitoring. And think about much more complicated mixing processes. And the verification of these processes is often time delayed, and the verification process itself is of course time consuming and even expensive. And therefore we wanted to create the prototype, and the main objective was to give a forecast, a real-time forecast about the homogeneity of the flow and the local temperature distribution, which is only based on two physical sensor data. And these sensor data are the volumetric flows at the inlet of our amp block. So with the real measured sensor data of these two inlets, we are able to give a real time about the homogeneity of the flow and the local temperature distributions. So now I want to hand over to Teresa to go on with the project approach.
Thank you. So you have seen or we have heard about the prototype and the use case, and I think it was very important to, at the beginning, discuss what is the best use case to start a project with the digital twin. So what we did is we did a workshop. We sat together with different departments at GEMÜ and discussed possible use cases, but also discussed what's the big picture, what they want to reach with the digital twin, and of course also have a look what's the added value for GEMÜ as the customers, but also for the GEMÜ customers, because at the end, the digital twin always is an instrument that should be used from both sides. And so we started with that in a first step, and also, of course, had a look at the IT infrastructure, at the different simulation models that were already used in the product development. And after that, we started with the prototype, and I think that was a very good approach to do it in a very short time. So we did the prototype in different milestones. If you call it MVP or proof of concept, it actually doesn't matter, right? But to have fast results and show that, then have the possibility to show that to different people. And after the prototype, we did the validation phase. We will speak about that later as well. And I think that's very critical. If you speak about digital twins and specific information that you deliver, it's very important to be sure that the information are right? And after that, we did then the feedback loop with management. We showed the solution different customers. So GEMÜ had an event 2 weeks ago, the GMotion, where they really showed the digital twin and went into discussion with the end customers, what was really interesting, and then to go and further develop the solution. So when we speak about simulation-based digital twins, I'm not sure if you are aware of the combination. It's actually what everybody knows, I'm sure, in this room, is you have a product, you have a component, you have different sensors, right? And then normally the challenge is, you know it, that you are not able to place sensors in all the places that you need, right? To really get the information and do the prognosis and the analysis. So what we do combine is that we have the existing component, and additionally we have a simulation model, and combine then actually the know-how that we have from the whole, let me say, product together with the know-how that we have from engineering, and then combine the two worlds and do analysis and predictions in combination of both sides or with both sources. So to go a little bit more deep down from the technology point of view, so like we mentioned before, you have the component, you have the simulation model, and if you work with simulation, you normally know that the challenge is that to create the model, it takes some time, right? So what we did here is that we used the method reduced order model to really make it real time, that you are able to real time measure the information that you would look like. And the combination of these two worlds has actually the nice advantage that you are able to place virtual sensors, and that's what we will show you in a second then as well. So this means you can place sensors virtually, right, and put it into the data set and use it further. As example then for predictions, for lifetime analysis, for what-if scenarios, and then use the information further in the company. So Marco will show you in a second then how the prototype looks like. But from the setup, of course, you have sensors. Then you have this reduced order model where you feed existing sensor data, put it in together, generate these virtual sensors, and then visualize it. And I think that's very nice here. So you see here the outlet that we discussed before, that you have seen, that is the unknown information, and we place there 25 sensors. So in the middle you see 25 sensors that we are able to measure now, and you see also with the colors the different temperatures, and we did that. Okay, and we did that, then of course put this information into an IoT platform with the visualization that Marco will show you, to really do the characterization of this mixing process and to get more insights and more information about the temperature, average temperature, homogeneity of the mixture. And I think that's what I really would like that you take with you, that it's not possible to have real sensor data at this outlet. And if this information is something that is really important, then with the virtual sensors you can combine it. So then I think, Marco, if you would take over and show the prototype.
Of course. Thank you very much, Teresa. as Teresa mentioned, with the simulation model, we are able to get information about local temperature distributions and the homogeneity. And with these simulation results, we are able to characterize our mixing process completely. And the information are afterwards displayed on a certain dashboard, which you can see here. And before I start a short video to show you all the nice features of this dashboard, I want to mention just a few words. As you can see, the dashboard is pretty simple, so it's understandable for almost every person. So you don't need knowledge about simulation techniques or mixing processes. It's understandable. So I will start a video and give you some information about the features. As you can see on the top, there are the real measured sensor data, sensor data of the volumetric flows. In the lower part of the diagram, you can see the volumetric flows of the real sensor data over time and also some virtual sensor data. So it's here, maybe you can see it's in the bluish line, it's the average, which is a simulation result. It's not only the actual data displayed here in the diagram, it's also some historic one. We are able to go even further into past with the use of calendar, which you can see here, and to go, even further into past. Let's check what happens if we change the volumetric flows at the inlet. So the process parameter change. You can see that the actual values of the sensors change, but the more important thing is at the right side of the slide, the results of the simulation change almost in real time. So, but we are not only able to display physical sensor data here in the diagram, but we can choose from a huge palette of, for example, real measured sensor data, but also some virtual or some virtual sensor data. So you can see a huge palette. That's the palette of, let's say, the physical sensor data, but the next one is the virtual sensor data, and you can see it's a huge palette, and it's mostly it's local temperatures in the fluid or information about homogeneity and standard deviation. So let's pick the standard deviation of temperature in the outlet cross section and the information about the homogeneity, and you can see that the diagram, according to the changes, dynamically adjusts, and now the actual and historic states of these values, so these virtual sensor data, are displayed in the diagram very nicely. A very important feature, in my opinion, is the next one. You can see a contour plot of the temperature in the outlet cross section, and with just one view you can see that the homogeneity of the flow is not good at the moment for these process parameters. But let's see what happens if the volumetric flows at the inlet change, so the process parameters are changed by our customers, and you can see that the contour plot dynamically adjusts in real time. So it's the simulation results in real time, which you can see here. And the last thing I want to point out is some kind of histogram of the temperature distribution, which you can see here now. And again, you are able to get information about homogeneity and local temperature distribution at the outlet cross section.
And I think this shows really nicely, this was the prototype that was done after 3 months, that the different points like virtual sensors, the combination, the homogeneity that was shown, how you can show that on an easily way to discuss it and then after further adapt it. And when we did that, of course, you get specific results, and then everybody's asking, okay, how good are the virtual sensors really? And so this means this actually is the next step that must be done, the validation.
Okay. As Teresa mentioned, yeah, of course, we wanted to perform the validation to evaluate this new technology in our company. So, and the results were very good. So we had a good fit between the predicted temperatures and the real measured sensors. And some words to the, let's say, the experimental setup used for the evaluation or the validation process. You can see it here on the screen. you can see, for example, the inlet of the hot and the cold water. You can see the physical twin, so it's the M block we use for our validation, and you can also see some sensors we use for the validation, so some temperature sensors. The last slides are considering some benefits for our customers and for GEMÜ as well, which is very important in my opinion as well. So just starting with the added values for GEMÜ. As I mentioned before, as Teresa mentioned before, there's no that today we are able to give live insight into the mixing process due to the virtual sensor technology, which is really one of the key technologies of the simulation-based digital twin. With this special kind of simulation model, with the reduced order model, we are able to have real-time capabilities, real-time calculations, and with the combination of the dashboard, we are able to give overview over actual and historic states of the mixing process. With these real-time capabilities, our customers are able to improve their production process, their mixing process in real time. Coming to the added values for GEMÜ, I said it before, so it's the reduced order model. It has real-time capabilities, and therefore we are able, in the research and development department, are able to understand the physical processes within the block much better. With the use of some specific sensor data of our customers' plants, we are able to predict or give information about the performance, the mixing performance of our M blocks in advance. Of course, we are able to create new revenue streams through these smart products and smart services, and transform to kind of a complete process solution provider for our customers. And the last thing mentioned here on the slide is a very important one in my opinion. So the capabilities of the simulation-based digital twin of this valve system is of course not restricted only to the simple mixing process of hot and cold water. It's transferable to almost every physical process. Coming to the end of the presentation, I want to give a short summary and some lessons learned. Of course, it's, in my opinion, very, very important to identify the best fitting start case for the prototype, which we did, in my opinion. So choose an agile project approach, not as that static one, starting with with the workshop, go on with the prototyping, the validation, and finally ending with the implementation into your IT infrastructure. Involve your management, get positive response by your customers, and with the help of CAD/CAM and ITficient, we were able to build up really essential technological in-house know-how and set up a scalable solution. And at the end, I want to give special thanks to Teresa Alberts and the whole team. It was, and really it still is, a pleasure to work with you, great partners of ITficient and CAD/CAM. So with these words mentioned, we want to come to the end of the presentation. Thank you very much for your attention.
Thank you.